Many unconscious processes within the brain profoundly influence our choices, challenging the authenticity of our decisions. Recognizing these processes can significantly reshape our understanding of free will. Neuroscience further suggests that the perception of a singular self might be an illusion crafted by our brains. This intriguing concept invites us to delve deeper into the complexities of consciousness and identity. Consider sleepwalking as an example. It illustrates how the brain can execute complex tasks devoid of conscious control. This phenomenon underscores the sophisticated nature of brain functions performing independently. During sleepwalking, the prefrontal cortex remains inactive, inhibiting self-awareness and decision-making. This inactivity enables other brain regions to manage movement without any conscious oversight. Consequently, while sleepwalking, the brain regions linked to motor control, vision, and behavior can activate without the individual's awareness. This suggests that our unconscious mind often navigates numerous daily decisions. Anesthesia induces a more profound loss of consciousness compared to mere sleep. The brain transitions from dynamic activity to slow, dull waves, representing a state of unawareness. Consciousness itself is defined by active cognitive processing, integrating sensory information that allows individuals to think and act meaningfully in their environment. This integration forms the bedrock of conscious experiences. Notably, split brain surgeries reveal the independent communication and functioning of the brain's hemispheres. These remarkable insights shed light on the complex nature of human cognition and behavior. The left hemisphere predominantly manages language and speech, while the right hemisphere focuses on emotional processing and visual spatial tasks. This division enriches individuals' overall cognitive capabilities. The corpus callosum plays an essential role in facilitating communication between hemispheres, enabling efficient information integration. In its absence, one hemisphere may operate without the other's awareness. Experiments with split-brain patients reveal that each hemisphere can independently process information, resulting in differing perceptions and responses when disconnected. This challenges the traditional view of a unified consciousness. Our brains comprise numerous regions, each responsible for distinct functions, illustrating that both internal and external factors significantly influence our actions and thoughts. This complexity calls into question the belief in total self-control. The trust game serves as an example of how emotions such as guilt can drive cooperative behaviors, nudging participants to return investments even when self-interest is an option. This scenario highlights emotions' pivotal role in social interactions. Brain scans indicate that the insula is vital in processing emotions and guiding decisions, effectively acting as a thermometer for social situations. This knowledge can enhance our emotional intelligence. Phineas Gage's accident starkly illustrates how damage to the brain's emotional centers can disrupt personality and social behavior. This case fundamentally transformed our understanding of the role of emotions in neuroscience. Research indicates that traumatic experiences can alter genetic expression, impacting health across generations. This finding underscores the significance of understanding environmental influences on genetics. In Bianca's study on mice, trauma was shown to heighten genetic sensitivity to particular stimuli, demonstrating how environmental stressors can instigate biological changes in offspring. The concept of agency is examined, revealing that much of our brain's activity occurs unconsciously. This discovery raises profound questions about the true extent of our control over our actions. A magic trick served to challenge the notion of choice, prompting the participant to reflect on decision-making and the predictability of their actions. It highlights the illusion of control that permeates our experiences. The experiment employed transcranial magnetic stimulation to illustrate how brain signals can initiate movement without conscious awareness, further revealing the complexities surrounding perceived agency and control. Results indicated that participants frequently felt diminished agency when external stimuli influenced their movements, showcasing a disconnect between intention and action. Agency is shaped by feedback following decisions, encompassing physical, social, and emotional responses that mold our perception of control and decision-making. This dynamic interplay is crucial for understanding our sense of agency. Our sense of agency is not merely a singular experience, it incorporates multiple brain processes contributing to our perception of authorship over our actions. This complexity reveals how layered and multifaceted our understanding of consciousness truly is. Creativity and improvisation often arise from relinquishing conscious control, allowing the brain to function in a fluid and spontaneous manner. This phenomenon underscores the importance of minimizing self-monitoring for peak performance. Interestingly, the brain's decision-making systems can complicate tasks you've already mastered, resulting in underperformance under pressure, particularly in competitive environments. Creativity resides within all individuals, surfacing in spontaneous, unplanned activities that reflect the brain's adaptability and responsive nature. In conclusion, awareness of unconscious brain processes can shed light on the influences behind your behavior, helping you identify areas where you can assert control over your actions.